of the butt. What does that mean? Like it's recently grown wood fiber?
Okay. Good afternoon, everyone. How did the homework go? Any questions before I start? Now you can ask me the question that actually from the practice, which are very close to your Moodle questions. Remember, the Moodle is due tomorrow at 11:59. So for those who didn't start, please make sure you do it. All right. So questions? Nobody? 1.10, 1, 6, and 11. Okay, very good. So we're going to do those. So I will start with number 1. All right. First, let us remember, let me write the problems number down so I don't have to scroll up later on. Okay, 1, 6, and 11. First, let us remember the definition of the average rate. So if you have any function f, so you have a function, whether you have the graph or a formula or anything, then the average rate of change is between, of course, for x between a and b, is f of b minus f of a. It means by how much the output change over b minus a. So that's what it is. And picture-wise, if this is a and this is b on the graph, b minus a, it means what we call the change in x. It means as your input goes from a to b, that's their input, by how much it's changed. That's my delta x from here to here. As the input goes from a to b, your output was here. Then it moved all the way up to here. And this is from here to here, this right here, that's my delta y. So that's the change in output. So this is the delta y over delta x. Okay, so that's the picture for delta x, that's the picture for delta y, and that's the definition for average rate. And that's what we're gonna be, all the questions should be around. Okay, so yeah, I read your question. Travis. All right, so now let's do number one. The number one will, of course, requires the graph. So I will put the graph in front of you. Right here is the graph. So this is a function. It's given to us graphically. And the question is, okay, is f increasing or decreasing on the interval between -1 and 4? So this is the graph, and we write the answers here. So between -1 and 4, is it increasing or decreasing? This is -1 and this is 4. So what will be your answer? Increasing or decreasing? Neither. Do you agree with your classmate? Absolutely. Because what's the function doing? It's going up, so it's increasing, and then it's going down, it's decreasing. So the answer is neither. Neither increasing nor decreasing. 4. A, absolutely correct. Neither increasing nor decreasing. Now, question number 2. What is the average rate of change of f on the interval from 1 to 4? So this is 1, and this is 4, and they want me to find the average rate. So we use the formula verbatim. So what's the average rate? The average rate for x between 1 and 4 is equal to the value of the function at 4 minus its value at 1 over 4 minus 1. Okay, so that's the formula. Now we have to pick up the values of the output from the graph itself. So we go back to the graph and we put up. So this is 1 and 4. What's the output at 4? This is 4. The output at 4 is, quickly, all of you, 4 is right here. What's the output at 4? It's absolutely a 0. So the output at 4 is 0. So I'll write it next here, and then I'll erase it when I am done with it. I don't like to write on my books. And what's the output at 1? If this is 1, we have to go all the way here. That's it. So if I go back here, that's the output at 1. So the output at 1 is actually, how much? 15. I don't have good eyes. You have better eyes than me. I want answers from you. All right. So 15. So what is f of 4 minus f of 1? Now that we picked up the value, so f of 4 minus f of 1 is going to be, f of 4 is 0 minus f of 1 is 15 over 3. So it's minus 15 over 3, which is minus 5. Okay, that's nice, because why is this average rate negative? What's causing this negative sign in this scenario? Let's go back to the picture. When x moved from 1 to 4, so now, as I told you, I don't like to write. Doesn't mean it's bad, but I don't like to write. So as x went from 1 to 4, what happened to the output? The large decrease, right? The output, if you watch, this is the value at 1, right here. And this is the value at 0. From here to here, definitely the value decreases. So the delta y here, the change in y in this problem, is actually negative because the function lost value. Between 1 and 4, the function lost value. So when I am computing f of 4 minus f of 1, the largest number is f of 1. So when I take the difference, I got a negative number, which is minus 15, which is negative. So between 1 and 4, because the function basically lost value from 1, the change is a negative change. So delta y here is minus 15. And the delta x is right here. So delta x really in my scenario, nothing, that's the delta x here, which is actually the 4 minus 1. So it's this change right there, which is going to be equal to 3. And the average change is this ratio, minus 15/3, which is going to give me the -1. Okay, there we are. So now let's do the last one. The average rate of change between -1 and 3. Okay, so now I need the average rate for x between -1 and 3. Okay, so it's exactly the same. So it's the output at 3 minus the output at -1 over. But we have to be very careful with sign. 3 minus parenthesis -1. Okay, so we have to compute this number. I go back to the graph because that's all I have to. And okay, I have to erase again. I hope I won't break this page. So that's gone. And this is gone. So I'm done with the first part. Okay. Question number 1. So I want it between -1. So this is -1. That's the output at -1. And 3. The 3, that's the output at 3. Question number 1. Is the average rate going to be positive or negative? It is the slope. Oh, it is the slope. Travis, it is the slope. I will mention that in a second. Okay, it is a slope. All right, I will tell you slope of which line. Okay, back to you now. Is the average rate of change going to be positive or negative? Between -1 and 3. It's going to be positive or negative. Immediately, you know it's negative because the function lost value. At -1, it was 15. At 3, it's down to 7, it seems to me. So it lost value. So we expect the function to actually have a negative average rate of change. So to compute it, I need to compute the output at -1, which is equal to 15, according to the picture. The output at 3, which is, oh, that says 8, sorry, right? That's an 8, which is going to be equal to 8. So these are the output. So it's just going to be equal 15, sorry, it's 8 minus 15. I should get a negative value over 3 minus -3, that's equal to 4, which is giving me -7 over 4. Okay, graphically what it is. First of all, what is the -7? At -1, so you can think of it like this. At -1, so my input go from -1 to 3. So the delta x is from here to here. That's the delta x. From -1 to 3, which is 4 units. So that's my delta x. And what is my delta y? So as my input change from here to here, my output was here. That's f of -1, and it went down all the way here. That's my delta y. So my delta y is the -7. That's by how much y change. And shouldn't be 7 minus 50. Is it 7? Okay. I trust you for that because I have to take off my glasses in here. I don't want to. Okay. So this will give me -8. Sorry. Okay. So from here to here is a 4. From here to here, this going down by -8. So the average rate is nothing more than the ratio between them, which is -2. Okay. Now your classmate is telling me, you know, is it a slope? And I agree, it's 100% a slope, but it's the slope of which line? The slope of which line? I'm gonna draw the line that this average rate will give it to you. It's the rise over the run. It's the slope of this line. It's the slope of this line. So if you focus on this line only, the average rate is the slope of that line. That's a point on it. So that's basically the run that you see here. And so that's the rise and that's the run. So it is the slope of a specific line. It's the slope of the line that's joining this point on the graph and that point on the graph. Okay. Travis, does this answer your question? Travis? Okay. All right, so this takes care of number 1. Now I will look at other problems. I saw 6. I will look at number 11 that gave some students also difficulties. Okay, so before I do that, I'll go back to my picture here for the average rate to talk more about the slope. So where does -8 come from? Okay, where does -8 come from? It comes from here. What is f of 3? This is 3. F of 3 is 7 because I saw it 8, but your classmates, I think, are right. That's f of 3. It's f of 7. It's 7. What is f of -1? It's 15. So what's the change? It's f of 3 minus f of -1. It means that's the 7 minus the 15, which is the -8. Okay? So before I move to number 11, and yeah, it is important because, so let me answer Travis' question one more time, and then I move on. So that's the general picture of the average rate. The average rate is the slope, but when you think about slope, we have to take slope of a line. This is not a line. This is something curving. So it's the slope of which line? It's the slope of this line, the purple one, the dashed line. It's the slope of the dashed line. Okay, so if I take the average rate between two other points, I will get the slope of another line. The slope is changing. I get a slope of a different line. So that's what the average rate represents graphically. All right. So let me look at number 11, and then I look at number 6. So number 11 is the following. All right. Before I do number 11, I do number 11, and then I go to number 8 because there were some issues with problem number 8. So let's see what's number 11 about. Okay, we read it. Suppose f is a function. Answer the following question. Suppose f of 1 is 8. So we know f of 1. And the average rate from 1 to 6 is 10. What is f of 6? So it's kind of a puzzle, but it's not really a hard puzzle. Let us read it verbatim and set this up as a question. So I have a function, I don't know what it is, and they tell me the following. They tell me the function takes at 1 the value 8. And the average rate of change from 1 to 6 is 10. So how can I interpret that? It means the average rate from 1 to 6, the average rate from 1 to 6 is equal to 10. And the question is find f of 6. How can I use all this information to find f of 6? Purely algebraic way. So I have a function. At 1, it takes the value 8. Takes the value 8. And then what do I know about it? The average rate between 1 and 6, it means as you move from 1 to 6, the average rate is 10. Okay. So this is from here to here, this is 5. The average rate is 10. And they want me to find what's the value at 6. Who has any idea? How can I even proceed in this problem? The only thing I know that because the average rate is positive, it means the function is actually going to gain value. Set it equal to 10. Very good. Set what equal to 10? Set the average rate equal to 10. Okay, we're going to do that. F of 6, this is my unknown. F of 1, I know it. It's 8. 6 minus 1 is 5. This should be equal to 10. So I will do it purely algebraically. It means f of 6 minus 8 over 5 equal to 10. So if I multiply, so I want to solve for f of 6. That's my unknown. So I multiply by 5 both sides. So this will give me that f of 6 minus 8 will be equal to 50. And it means basically that's the change in y. The change in y is 50. It means f of 6 has to be 50 plus 8. This is equal to 58. So f of 6, it's really, really, really huge. So this is off the chart. My scale is absolutely not right. So f of 6 should be equal right here to 58. Okay, so now let us check. So my function, so this is my f of a. So I don't know how my function is, but I know that that's really my function. It's going to be something like that. So from here to here, now I have 50, because that's 58 minus 5. That's my delta y. So my average is 50 over 5. My average is actually that. It's a little bit tricky, but it's again not too bad. All right. So I'll give you 2 minutes to do the second one. So now the question is, so this is all of you. I want you to attempt this part 2 of this problem. So part 2 of the problem is the following. Suppose f of 6 is 22. There. F of 6 is 22. And the average rate, so f of 6 is 22. The average rate of change from 1 to 6 is 4. And now they want you to find f of 1. So I'll give you a minute to be able to deal with it the same way I've dealt with it a minute ago. See if you guys follow. So use this info. Use this info. So please, every one of you, try it. I don't even know the answer, so you guys will do it, and then I'm going to do it with you. Anybody got any answers? Okay, I'm getting 2, I'm getting 2, I'm getting 2. Okay, let's check it out. Let us, please, when I ask you the problem, every one of you try it. Average rate of change is 4. How can we read this? It means f of 6 minus f of 1, the change, over 6 minus 1, this is equal to 4. That's what it means. And I know that f of 6 equal to 22. So it means that f of 6 minus f of 1 over 5 is equal to 4. Okay, so multiply by 5, it means the change is 4 times 5. It means the change in y is 20. So it means, as I know, if this is 1 and this is 6, when x go from 1 to 6, I know that means the output here is changing by 20. That's really, this is the 20. That's f of 6 minus f of 5. And this is the 5 right there. That's really my picture right here. Now I know that, we know that the output at 6 is 22. So this will give me 22 minus f of 1 is 20. And now I solve for f of 1. Then give me f of 1 is equal to 2. And you guys gave me a correct answer. So this means that this is f of 6 and this is f of 1. And my function hanging somewhere in there. So this is 6, 22. And this is here 1, 2. So as exchange went from 1 to 6, my output went from 2 to 22. It means my output changes by 2. So I have to almost finalize this. There is one question, which is number 8. I will not do all of it. I will do only 2 parts because the question, in the equation, I got -2. No, let's do it slowly. How do I solve for that? So this is your unknown. This is what you're looking for. So you can put, if you want, minus f of 1 equal, you subtract 2 from both sides. You get -2. So if you multiply by -1, you get f of 1 equal to 2. Okay, so just do it again. It's an algebra mistake. Sage, got it? Yeah, sure. Very good. Now, when I look at number 8, not all of it for sure, but only basically 2 questions because I had, you guys asked me about that. So it was minus x squared plus 25. So in your Moodle, you have a little bit harder than that, but that's really the idea. So I will answer 2 questions only. So the easy one is find the average rate of change for x between 1 and 4. Okay, that's the easy part. So the average rate of change is nothing more than f of 4 minus f of 1 over 4 minus 1. So to compute it, we need either one. So let us compute f of 4 here. What is f of 4? Watch, there is a minus. 4 squared plus 25. The minus is in front. It means minus 16 plus 25. Now minus 16 plus, let's give me the plus 9. That's f of 4. F of 1 is minus 1 squared plus 25. Minus 1 plus 25. This will give me 24. So I did that on this side. So what is my average rate here? 9 minus f of 1 over 4 minus 1, which is equal to 3. So now we will have minus 24. 24, you take away 9, you get 15. I meant minus 15 over 3, you get minus 5. It means between 1 and 4, because the average rate negative, definitely we know that the function actually lost value. At 1, it was 24, it's lost value all the way to 9, causing this negative sign. Now, the problem that a lot of you had difficulties with was the following, if my memory is correct. Find the average rate of change for x. So that was a very symbolic one, t and t plus h. Okay, so it is symbolic, but we should be able to handle it. It's not very hard. What's the average rate? Again, the formula doesn't change. It's f of t plus h minus f of t divided by t plus h minus h. The value here minus the value here. So the change over the change in h. So that's, as I said, purely symbolic, but we should learn a little bit how to handle it. Plus h minus h is just a t. And now this is f of t plus h minus f of t. Now I want to compute each one of them separately and then combine them again. So let's do f of t plus h separately. What is f of t plus h? Equal. All right, that's the function. I'll put the function in red in front of us. So I will put it a little bit in red. here. Okay, so that's my function. So I have to refer to it all the time. Plus 25. So what is f of t plus h? It means wherever there is x, I put a t. But never forget the minus. So it's a minus the quantity t plus h squared plus 25. Okay. Oh. Thank you very much, Travis. Thank you very much. All right. So this is equal to minus, what's t plus h squared? T plus h plus 25. Be very, very careful with, okay, with this sign. So it's going to be equal to minus, I'm opening my bracket, plus 25. Minus is still there. I want to distribute t squared plus th plus th plus h squared. Now I'm almost ready to start simplifying. This is going to give me t squared. Those two now could be combined into 2th plus h squared plus 25. Finally, I can distribute the minus. So it's keeping track with the minus that gave us difficulty. So that's f of t plus h by itself. I'm very sorry about the mistake I did right there. It's t plus h minus t, which give me an h. Please, for those, I mean, you guys corrected me already. For those who are writing down, please be careful of my stupid mistake. It's t plus h minus t. T minus t cancel out, we're left with h. So thank you very much for those who are keeping up very well with me. So now we have to, we computed f of t plus h. So I did them separately on purpose. And then we need f of t. So what is f of t? So f of t now would be, again, minus t squared plus 25. There is really nothing to simplify about it. That's what it is. However, f of t plus h, of course, is more complicated. Now I go back and I plug in everything for my average rate. So let's go back to the average rate of change. So it's equal to, considering my mistake, this should be h, and this is f of t plus h. Now I collect what I have, and I do f of t plus h. It's minus t squared minus 2th minus h squared plus 25. Watch, always parentheses, minus f of t. Now what's f of t? Again, parentheses, minus t squared plus 25. You lose your parentheses, you lose a lot. So now we're done. We just have to kind of simplify. So let us simplify. This is equal to, this is my h. And now let's do that. Minus t squared minus this, minus h squared, plus 25, minus, minus, plus, minus 25. Okay, so finally I see what I can get rid of. Plus t squared minus t squared will go away. Plus t minus 25 actually go away. And now what I will be left with is minus 2th minus h squared over h. The last step, which is because we have to get used a little bit to simplifying. If we notice very well, here I can pull my h, leaving me with that. Okay, I factor it out. Let me see, this time that minus 2th minus h squared. This will make usually this expression much simpler, leaving me with that end of the problem. All right, so this is the question that some students had difficulties with, and that's how we do it. All right. The last thing I will do is the following a problem, and then I will move on, and I will assign number 6 again for next time because I need to start a new section. The last problem I will do for every student who started Moodle, they struggled with one question. So I'm gonna a little bit go over it, a little bit, and then I'll let you struggle with it in your homework. So I will put the problem here. Okay. And it's a little bit bizarre, but it's a nice problem. Draw the graph, because you have to be a bit creative here, of any function, so you have to draw, that has the following property. As x goes from 1 to 3, the average rate is -1. So I want you to draw a function such that it satisfies the following property, basically. The average rate of change, that's what they want, for x between 1 and 3 is -1. That's really what they want. Okay, so it means what, Moodle doesn't work on the iPad. The graph, Moodle's graph don't work on iPad, so try to use anybody else's computer for that. Yeah, laptop, it should. My understanding, it's iPhone and iPad where it doesn't work. That's really my understanding. Otherwise, so try it again. If you try it again on a laptop, but not an iPad, and see if you still have problem, let me know. I will tell the person who's doing it. Okay, so average rate of change is -1. So how are we gonna sketch the graph? It means what? It means the change in y, so that's really what it means, over 3 minus 1 equal -1. It means that the change of y between those two values over the change in x is equal to -1. Okay, so how are we going to sketch a function to satisfy this property? Here it is. So that's my function. And there are a lot of cases. This is 1, and this is 3. And I'm going to graph a function that the average rate between 1 and 3 is -1. Right. I can pick anything I want at 1. I don't really care which value you pick at 1. But here's the thing. What's happening is that we know that the delta y over delta x is negative. It means the function has to lose values. That's important. We know that if x change from here to here, that's the delta x. The delta x is 2. As x change, y is going to decrease. But how is it going to decrease? The rate of change has to be -1. So how I'm going to use that? I'm going to use it like this. And then picture is becoming clear. The delta y over delta x is -1. But the delta x is 2. Because as you move from 1 to 3, delta x is 2. It means the change in y over 2 should be -1. Which means that I want the delta y to be -2. So now how can I graph my function so that the change in y to be -2? If this is delta x, I want the function to go down by 2. I go down by 2. And now how you want to graph? Just connect dots. This is your function. Okay, so you pick one, whatever you want. It doesn't really matter. What you want to make sure of is that the value at 3, you should choose it so that the rise over the run, if you want, is -2. So if you want delta y over delta x to be -1, because delta x is 2, it means that you multiply by 2 both, you get the delta y to be -2. It means you have to go down here, that's the delta y. The delta y should be -2. So whatever your value is, you go down by -2. And that's how you get your graph. Okay, please don't talk about points, talk about really understanding those problems, all right? Okay, so give it a try. It's a fun problem to play with. Okay, any other questions before we proceed? Okay. So today we're gonna go to a scenario that you, I know that number 6 is holding, so please work on number 6 a little bit more, and next time I will take it up. Today we're gonna start section 1.11, which is very much what you know. So section 1.11 is basically about linear function. Okay, so linear function, it means we're going to talk about lines. What's a linear function? A linear function is a function, it means a rule. We give it an input, it gives you an output. But so that when we graph it, we get a straight line. That's what a linear function is. So today we will focus more about how to find a formula for it. Next time we're gonna focus more, it means what characterizes linear function. So today it's going to be focused on one aspect, is how to find a formula for it, or in other words, we're going to study the equation of a line. Okay, how to find the equation of a line. Now, I know that you've been learning this since middle school, but we have to learn it very well now. So first, what is a line? That's a line. Straight line, straight. That's what a line is. And whenever we study line, the first thing we study is what we've been talking about it for a while now, the idea of a slope of a line, which is nothing more than the average rate of change. So first, slope of a line. So if I have 2 points on a line, 2 points, any 2 points on the line. So suppose I have 2 points, x0 or x1, suppose x1, y1, 2 points. So I'm gonna give them a name, and x2, y2 be 2 points on the line. Okay, so this is my first point, x1, y1, and this is x2, y2. Now, what is the slope? Slope is what we actually have been talking about it before, is the average rate. So what is the slope? Okay, you imagine this is a line. As you go from, this is my x1, and this is my x2, and this is my y1, and this is my y2. So the idea is the same. As you go from this point to that point, there is a change. X was here, X became here. So that's the delta X. And the Y was here. It went up all the way here. This is the delta Y. So the rise over the run. So the slope is nothing more than the change in Y, which is y2 minus y1, which is the delta Y, over the change in X, which is x2 minus x1, that you guys call the rise over the run. So it's nothing more by how much the Y component changed by going from this point to that point, over divided by how much the X component changed. Now, what characterizes the line? What characterizes the line over any other function is the following. If I take, we can use geometry to prove that. If I take any 2 points on the line, any 2 of them, and I compute the rise over the run, it means I compute the change over the change, I get the exact same answer. That's because of the geometry of the line. No matter which point I take, the rise over the run have to be the same. This is not true if my function is not a line, if my graph is not a line. And that's where the average rate came into the picture. So if my function, let's get that very clear. Suppose my function is curving. Curve, like that. If I take this point and that point, 2 points, so that from here to here, there is 1. And then I take this point, so I keep the change in x the same. So the rise over the run is not the same here. You can see the delta y is very large. The delta x is 1. The delta x is delta y is much smaller, over 1. So if the function, if the graph is not straight line, it curves, then the delta y over delta x changes. That's why we talk about the average rate between 2 points, because it's not constant. If what you're graphing is a straight line, then this average rate is the same. And that's what we call the slope of the line. And as we all know, we use the letter M to denote the slope. Okay, so let us find two slopes that we've been doing the whole hour today, and then talk about the equation. So example number 1. Find the slope of the line. And now I'm talking about line. Otherwise, I cannot talk about slope. I cannot talk about slope of the curve because the change of x changes if a function curves. Just on the line, I have the right to talk about slope of the line. So find the slope of the line, joining the following that go through or that pass it through the point. Okay, let's just make up any 2 points that you're gonna start pass it through. Let's pass through the point 1, 4, and let us say 6, 8. So I'm only interested in the slope. All right. So what's the slope? So here, these are my points. I usually like to put them in front of me. This is my x and this is my y. 1, 4, 6, 8. Now, so what is the slope? Okay, so basically it's the average rate. As x changed from here to here, the y changed from here to here. So the slope is 8 minus 4 over 6 minus 1, which is 4, right? 6 minus 1, that's, which is equal to 4/5 and of the problem. Okay, so this is really the average rate. It's exactly like the idea of the average rate of change. Now, suppose I give you the following. So suppose example 2, find the slope of the line, okay, that passes through the following point. Let me make another bunch of points. 1, 4, and 6, 0. Okay, so 1, 4, and 6, 0. So this is what I have here. This is my x, and this is my y. 1, 4, 6, 0. So my graph here, I always like graphs. 1, 4, so that's a point on the line. 6, 0, so that's a 1. 6, 0, that's another point on the line. So it means I need the slope of this line. So immediately, do we expect a positive or a negative answer? Immediately, what type of answer do we expect? Okay, it's going to be 6, 0, minus 4 over 6 minus 1. It means minus 4 over 5. Descending slope, definitely this is going down. The slope is going to be a negative answer. Right, so the first thing about the slope, and then we move on to the equation here. So in general, we have the following. If my line rises, the slope is positive. My lines fall, the line increases, if you want, increases. And here, if the line decreases, the slope negative, the line decreases. Okay, so at least we know whether my slope is going to be positive or negative, whether we realize that the values of x, when x is increasing, the values of y are increasing, or whether they are decreasing. Very good. Now, a little bit more about the slope for a line. So some interpretation of the slope. And we will talk a lot about the interpretation next time when I have problems that have physical meaning. For now, geometrically, what does the slope mean? Suppose I'm going to draw a line for you. Just a line. And I'm going to say the following. That's a line. And you're given, I'm not telling you anything, I'm just telling you that you're given that the slope, so it's on the spirit of the problem I've been doing today, the slope is 2. Okay? So the slope is 2. And I'm going to give you 1 point on this line. Suppose I tell you this is a point on the line, 1, 3. What does it mean the slope is 2? So the slope is 2 means if I start from here and I move 1 unit, so my delta x is 1. Okay, my delta x is 1. What should be my delta y? By how much we should rise? So if I go by 1, well, how much I should rise? Now, if the slope is 2, it means the delta y over the delta x is 2. So if I choose my delta x to be 1, it means the delta y should be 2. So if I tell you the slope is 2 means if you take any point and you move by 1 unit, if you make the run to be 1, crucial, the rise is exactly the slope. So this is equal to 2. Okay, and this is everywhere. So if I take any point here, I move by 1 unit, I go up by 2 units, which is the slope. So this gives us really a nice interpretation of the slope. The slope, I know it's rise over run, but actually a nice interpretation that make it for me very easy to understand. It is the rise per unit of run. It means every time per unit of run. Now it means that the slope is the delta y when the delta x is equal to 1. So it tells you by how much we go up or down when the change is equal to 1. And that's interpretation of the slope actually help us a lot understanding the slope. Okay, so it tells me how much we go up, how much we go down if my x changes by 1 unit, because it's this ratio. It's this ratio. So if this is 1, the slope is going to give me the rise. So this leads me to the following simple question. Suppose I do the following. I tell you, sketch a line. Sketch a line that I'm going to give you 2 things about it, that passes through the point let us say 2, 4 with slope -3. Can I sketch this? Is it easy to sketch a line? Okay. So I want a line. The line passes through the point 2, 4. This is 2, 1, 2, 3, 4, and this is 4. That's the point on the line. And please wait for mx plus b. Okay, I know that you guys been taught mx plus b since middle school. I'm fully aware of that. All right, so this is the point 2, 4. And I want the slope to be -3. What does this mean for us? It means that if the delta x is 1, the delta x is 1, the delta y over delta x is -3. It means the delta y, since I substituted 1, is always -3. It means if I move by 1, the graph is going to go by 3 units, 2, 3. So that's another point on the graph. So that's the delta y here, which is -3. So the slope is the rise or the fall per unit of run. And my line now is nothing more than that. That's the line. Okay. So this tells me that if I know a point, 1 point, and I know the slope, I basically can draw the line. I know everything about the line. So yeah, so for x, you always move over it. Yes, x always to the right, always. X doesn't move backward. We always move to the right. We move to the right by 1. The y go down by the slope, which is -3. That's what gives me my other points. Now, if you look at this line, the red line, the slope. So if this is, for example, 2, 4, now we know what this point here. That's 3 because I moved only by 1. And this one, we are at 4, we went down by 1. This should be 3, 1. So I really know my line very well. So knowing a point, knowing the slope, give me the line. So now the question is, as one of your classmates really wanted me to do, is the following. If this picture tells me that if I knew 2, 4, I knew the slope, I was able to figure out this point on the line. The question is, can I find an equation that relates so that if I know the x, I know the y. So finding an equation, since those two will help me to find the line, so basically those two should help me to do the following. If I know, take any point, is there a way if I know the x, I know the y? That's what we call the equation of the line. Now there are several ways of finding the equation, 2 main ways. One way is the y equal mx plus b that I will not start with. I'm going to start with another equation that I think it's very important, and usually as you do calculus, you will use it more. So now the question is, find the equation of a line. And as I said, we will do it in 2 different ways. So equation of a line. Equation of a line. So we saw the slope, we saw the importance of the slope and the geometric meaning of it. Now the equation of a line. So let me make clear, what do we mean by equation of a line? Equation of a line means, if you have a line, finding the equation means, find an equation so that if you know the x component, the equation will allow you to find the y component. That's really what it means. What relates points on the line? So equation of a line. And as I said, the first way we're gonna learn is what we call point slope form. So we're gonna learn how to find an equation using something called the point slope form of the equation of the line. So we're gonna do it, as I said, in 2 ways of a line. So that's the first way we're going to learn how to find the equation. And then y equal mx plus b. All right, what's the point slope form? Suppose you have a line, this is a simple line. And so suppose L is a line. And let us say you know the slope. Suppose the slope, I'm going to call it M. And you know a point. And x0, y0, a point on the line. So suppose you have a line, you know a point, and 1 point, and you know the slope. And as we said a minute ago, if I know both 2, I can draw the line. So suppose you know this, and you know the slope. And now my goal is to tell you how to find the equation relation between x and y. All right, let's see how this works. So where the formula is coming from, and then how to use it. The idea is where the formula coming from. It comes from the following fact. If I take any point here on the line, I want to find the relationship between them. So I'm going to say the following. Suppose xy is any point on the line. Just any point. Okay, any point on the line. Then, any point, I don't know. If I compute y minus y0 over x minus x0, I should get m. Am I correct with the statement? If this is any point on the line, regardless what it is, this is I know, this is I don't know. But the only thing I know that if I take y minus y0, I divide it by x minus x0, I should get that. Now I'm going to multiply. I'm going to multiply by x minus x0. I'm going to multiply by it. And this would give me y minus y0 equal m, the slope, x minus x0. Totally memory. This is called point slope form of the equation of a line. Point slope form of the equation of a line. So it's a form that will help us to find the equation of the line fairly simple. It's called the point slope form of the equation of a line. So let us use this form immediately. So I'm going to take a line and we are going to use this form to find the equation of the line. Not y equal mx plus b. I'm going to use this form to find it. So here is my problem. Find the equation of the line. Find the equation of the line. Find equation of the line that go through the point through the following point. 1, 4 and 6, 8. Okay. So, and I keep this formula in front of me very clearly so you guys know exactly how I am using it. So now I have a line. No, actually, let me use easier number just to make it. So 1, 2, and 3, 8. It doesn't really matter, but I want I don't want the number to be problematic. And 3, 8. So please, if you're writing, change 1, 2, and 3, 8. Okay, so equation of this line. So it's 1, 2. That's a point. 3, 8. So right here, that's my line. So I know the 2 points. So that's 3, 8. And my goal is the following. So my goal is that if I know the x, how can I find the y of any point on this line? So let us do that quickly using this form. To be able to use that, we need the slope. So first we're gonna find the slope. So my point are 1, 3, 2, 8. So the slope is 8 minus 3 over, it's 1, 2, that's what I put, and 3, 8. So it's 8 minus 2, 8 minus 2, divided by 3 minus 1. That's 6 over 2, which is a 3. I know M. Now, point. I have 2 points. You can pick any one you want. 1, 2. So I have a point. I have the slope. Now I'm going to use this verbatim. So what's going to be the equation? The equation would be, watch how I'm using it. Y minus y0, m x minus x0. So for me, this would become, my point is 1, 2. So this is 2. The slope is 3. X minus x0 is 1. So it's really very easy to use. Once I use it, and then I try to write y explicitly in terms of x. What do I mean by that? And then I solve for y in terms of x. So this will give me 3x minus 3. It means the y, we add 2 both sides. So we add 2. So y will be equal 3x minus 1. And that's the form that you are really familiar with. But the way we got to it is basically by using the point slope form. And do I want you to do it? Definitely. Would I ask you to do it? Definitely. Expect that. All right, so one more problem along the same line, and then we move back to this. So another simple problem, and this one I want you to be able to do it. Find equation of the line using the point slope form. Where do I get the minus 2 from? The point is 1, 2. That's the point. It doesn't really matter. Whether you pick this one or that one, it doesn't matter which one you pick, you will get the exact same answer. Pick the one that you think it's easy. It doesn't really matter, absolutely not. Okay, so now I'm gonna give you another one. I hope my answer is, so find the equation. Again, I want you to use this format. So, part A, equation of the line that passes through the following point. So the point I want are, I hope they are not, minus 1, 4, and 2, minus 2. So let us put them here. These are the point. I wanted to take minus 1 to 4, 2 has to go to minus 2. Okay, these are the one. So I wanted to find the equation using verbatim the point slope form. And then you write it in the format that you really, mx plus b. But that's the form I want you to use. So graphically. So you guys have 2 minutes to do it. Get going. I want answers. All of you do it. Okay. We done? Minus 3x plus 1, Travis. Anybody got anything like Travis? I didn't do it because I usually like to do it with you. Do you agree with him? I don't know. Nobody says yes. Okay. What's the slope? What did we get for the slope? So the slope is minus 2 minus 4, that's the change in y, divided by the change in x. But by how much x change? It's 2 minus, be very careful, minus 1. Be very careful, minus 1. Why it is minus 1? Because from minus 1 to 2, you're actually changing by 3 units. That's intuitively what's happening. If you use the formula verbatim, it's x2 minus x1, but x1 is negative. So you get minus 1. So now if we do the math, you're gonna get minus 6 over 2 minus 1, which give me the 3, making the slope minus 2. Okay, so be very careful with your sign because it affects the whole problem. So for those who got minus 3, it should be minus 2. Okay, very good. The point, as I said, you pick the one you like. Doesn't really matter because the slope is the same. So the only thing that you pick the one you like, the one you think is easier to work with, and the only thing you have to be very careful is the point, is the sign. So let me pick this one, minus 1, 4. You don't have to pick this one. If you pick another one, you get the same value. And now what's my equation is gonna become? So the equation would be, so verbatim, mx minus x0. Okay, so let us replace. So y minus my point, this is my point right there. So this is 4. This is my slope. And this is my x. And this is x0, but very careful. My x here, my point has negative 1. So this would give me y minus 4 is minus 2 times x plus 1. And finally, I just rewrite it. I just write y in function of x. I distribute minus 2. And then I'm going to add 4 so I can totally isolate my y. So that will give me minus 2x plus 2. Okay, so that's how we can find the equation of the line. It means the relationship between the x and the y if we use the point slope form. So suppose now I ask you the following. I'm still talking about the same line, nothing really different. My second question is find the y-intercept. What does it mean to find the y-intercept? What does this mean? No, if you add 4 both sides, you get minus 2x, minus 2 plus 4 plus 2. Got it? Yeah, that's no problem. Now, find the y-intercept. What do I mean by finding the y-intercept? What am I after? If this is the line, finding the y-intercept, it means I need to find that. So how do I find this point on the line? Quickly. So find the y-intercept. It means I want to find this. So I know now that this line, where I knew only 2 points, okay, then the equation is y equal minus 2x plus 2. That's the equation. So if I will need to find the y-intercept, means I need to find this point. What shall I do? No, the y-intercept, x equal to 0. Right, in this case, right here, 0, x is 0. So basically I need to find the y. But this equation tells me that if you take any point, that's the relationship between the x and the y component. So if x is 0, this will have to be 2. Okay, so find the y-intercept. It means we set x equal to 0. We don't solve for 0, we set x equal to 0 in the equation of the line. So this will give us y equal 0 plus 2. It means my y equal to 2. So in the picture here, when I put x equal to 0 in here, this piece here, this is usually the y-intercept. That's the b. It means that's where your graph will intercept the y-axis. And this piece right there, this is really the slope. So in the equation, the minus 2, that's the slope. because that's what you're multiplying x. And this here is the y-intercept. This is where your graph intercepts the x-axis, right? And this will bring me to the second form of the equation of the line, the one that the students are usually, they actually use the most. So the other equation, another way to find the equation of the line, but as I said, I want you to learn both. So what we call the slope intercept form of the line. The slope intercept form of the line is that, suppose we have a line, L is a line. So that's another way to find the equation. There are two different ways. The one I just talked about in length, and then the other one. Suppose as in a line, and M is the slope. So you know the slope. And B is, so B is the intercept, y-intercept. B is the y-intercept. It means this is the y-intercept. So I have a line. I know what intercept the y-axis, and I know the slope. What's the equation in this scenario? Okay, so the equation will become the following. So if I know the y-intercept, B is the y-intercept, it means if I take the following point, 0B, this is on the line. So what's going to be the equation? So if I use the slope intercept form, the equation is going to be the following. If 0B is on the line, it means if I put B here, and I simplify equal mx, it means, and I add B, the equation will become mx plus B. Okay. So the other form of the equation of a line, or another way to find the equation of the line, is that if I know the intercept, the equation will become the slope times x plus b. And b usually is where they intercept the x-axis. So now my one more problem, and then we're done. Find the equation of the line that passes through the point, following point. So I'm going to repeat a problem that we did a minute ago. So -1, 4, and 2 minus 2. But now I want you to find it using the slope intercept form. So I want to do the same problem, but I want it to be done using the slope intercept form. And I want you to be able to do the question in both ways. So how do we use the slope intercept form? Okay, we use it like this. Okay, first we need to find the slope. Slope is, so the slope intercept form tells me that the equation is the relationship between x and y is, this is the relationship, a slope x plus b. Now, if I know 2 points, I know the slope. So m is easy to find. We just did it a minute ago. -2 minus 4 over 2 plus 1, which gave me the -2. Okay. So I know my slope. So my y now is -2x plus b. But to be able to find the equation, I need to find b. So how do I find b? To find b, I say the point -4, I pick a point. Suppose I pick this one, on the line. It means that if I plug in, what does this mean on the line? On the line means that if I plug in -1 for x and 4 for y, this equation should be satisfied. So to find b, I said, okay, since -1 over 4 is on the line, it means if I plug in 4 for y and -1 for x, this equation should be satisfied. So basically at this stage, I have an equation that has an unknown, which is b. how to find it. I said, if this point's on the line, then this is satisfied. So this would give me, and now I solve for B, means B equal to 2. And this would give me Y equal minus 2x plus 2, which is we got another one. Okay, so to find equation of a line is, we can do it 2 ways. And as I said several times by now, I want you to know both. And I expect you to be able to do it in both ways. So the first way, either we start from the point slope form, and then we solve, we get our equation. The other way is we start with this form. We find the M, usually it's either given or enough info. Once I have the M, I find the B. So we can use either possibilities to find the equation of the line. And usually in calculus, we start using this one more. I would like you to know both of them for next time. Okay. Any other questions before we go? All right, so make sure you finish Moodle and make sure you do the home practice problem for next time. Bye for now. If anybody has questions, you guys can stay and ask, but the class is done.